This is GATE 2013 question number 30, which states that consider a gas of atoms obeying Maxwell-Boltzmann statistics. The average value of e to the power iota a dot p over all momenta p of each of the particles, where a is some constant vector and a is its magnitude, m is the mass of each atom, T is the temperature, and K is the Boltzmann constant, is what? So we need to find out the average value of this particular quantity e to the power iota a dot p, where a is some kind of a constant vector with magnitude a and p is the linear momenta or all kind of momenta of the particles. M is the mass of each atom, T is the temperature, and K is the Boltzmann constant. So this is what is given, and the gas follows Maxwell-Boltzmann statistics. So let's see what is the solution. So as given, I have just written it, the gas obeying Maxwell-Boltzmann distribution and Maxwell-Boltzmann statistics. We need to find out what? We need to find out average value of e to the power iota a dot p. P is the momenta, which is nothing but the definition is mass into velocity. Maxwell-Boltzmann distribution function can be written like this also, that is f of vx, vy, vz, which is the functions of three directional velocities, and that is nothing but n a cube e to the power minus b v square, where v square is nothing but vx square plus vy square plus vz square. I can write this as v square. It is absolutely fine. Now I will define a and b later. This comes from actually the Maxwell-Boltzmann statistics or the kinetic theory of gases also. We can also find out this kind of an expression. Now the definition of averaging of any particular quantity, say some x bar, is you integrate all over the domain minus infinity to infinity in all the three directions, and this is the x which is whose averaging is being done into this f of vx, vy, vz. So that is what I have written. So this is n a cube e to the power minus bv square dvx, dvy, dvz divided by the, so it is just like x into f of vx, vy, vz. Similarly dvx, dvy, dz, you have to integrate. So of course all three integrals will be there because three directional, divided by the simple f vx, vy, vz dvx, dvy, dvz. So this is the actual definition, and I have written it, this f vx, vy, vz. I have just put it this particular expression. Now if you integrate all these things, particularly the denominator part, you will find out that this integration of this, so I have written here minus infinity to infinity, minus infinity to infinity, minus infinity to infinity, a cube e to the power minus b vx square plus vy square plus vz square dvx, dvy, dvz is equal to 1. It can be easily proved using gamma function. So I have just written this particular thing, that this is actually equal to 1. If it is equal to 1, then x bar becomes, there is an n which is there, so it will come out and it will stay 1 by n and the numerator part. And you can easily chop out this n in the numerator and the denominator. Why? Because the integration is respect to vx, vy, and vz, not with respect to n. So we can chop it out. So after chopping all these out, the final definition of average comes out to be like this: minus infinity to infinity in three directions, three integrals, x whose averaging is being done, a cube e to the power minus b vx square plus vy square plus vz square dvx, dvy, dvz. That is the average definition, where a comes from the kinetic theory of gases. A is actually root over b by pi, and a is nothing but m upon 2 pi kbt to the power half, b is m upon 2 kbt. So these are coming from the kinetic theory of gases. So taking the average of e to the power, now this is the question which asks that e to the power iota a dot p, you take its average and find out what is the value of this particular thing. Now a is given as a constant vector, so I have just written it like this. P is also something like this in three components, x, y, and z. And finally just put it in this kind of a definition: minus infinity to infinity, minus infinity to infinity, minus infinity to infinity, whose averaging has to be done, e to the power iota a dot p. A cube is this, e to the power minus bv square dv, where v square is vx square plus vy square plus vz square. A is ax plus axi cap plus ayj cap plus azk cap, and P is pxi cap plus pyj cap plus pzk cap. Now I just open it out. If you take the dot product of these two, it will be just nothing but these two. If we dot it, dot product is being done, scalar product is being done, then it will be ax px plus ay py plus az pz. That's what I have written here. This is as it is a cube e to the power minus b. B is m upon 2 kbt, which I have written here. V square, I have just opened it as vx square plus vy square plus vz square, and the integral is in dvx, dvy and dvz. That's all. Now what I do is that they are all independent integrals because x, y, z are mutually perpendicular. They are orthogonal to each other. We can take each integral and solve it. So I will just solve one of the integrals. The other will be exactly similar to that. So solving x integral. So I have taken e to the power, just only thing, these things, e to the power iota ax px. A cube I have not taken. So what I have done is that only this portion and this portion I have taken. E to the power minus m vx square about 2 kbt dvx. Of course, m by 2 pi kbt to the power 3 by 2 remains as it is because it's a constant. Now, so if I take only this particular term, what we get is that e to the power minus, I can just rearrange it like this, m vx square upon 2 kt minus iota ax m vx dvx. Now m upon 2 kbt I have taken common with a minus sign was already outside. So m upon 2 kbt, this becomes vx square because this is gone already outside the bracket, minus 2 iota ax vx kt. This is what we have got. Now what I will do is that we try to make it as a perfect square. So it becomes vx whole square minus 2 into vx into iota ax kt, means this term is now written here. So this, if I have to make it a perfect square, then I have to add iota ax kt whole square minus iota ax kt whole square and then integrate with dvx. Now finally we will get e to the power minus m by 2 kbt, and this particular portion, this is particularly this one, I will take out because vx whole square minus 2vx into iota x kt plus iota x kt whole square, this together will give you this particular term, vx minus iota ax kt whole square. Okay, because this becomes the perfect square. So this is the extra term which I can take it outside because it does not have any vx in it. I can easily take it. So iota square becomes minus plus, so that can come here and becomes minus max k square t square divided by 2 kt. So I can chop some more terms, and finally the outside part, constant part, becomes this e to the power minus m x square kt by 2. Just the mathematics. Minus infinity to infinity e to the power minus m by 2 kbt vx minus iota ax kt whole square dvx. That is what the simplified integral. Now I will put some substitution. So y is, suppose this one, vx minus 2x kt. So dy will be dvx because this is the constant. So e to the, this remains as it is. Minus infinity to infinity will also remain as it is because if vx is in minus infinity, y will be also minus infinity. If vx is infinity, y will be infinity. E to the power minus m upon 2 kbt as it is written, and this is y, so y square dy. Again I have to substitute t as m by 2 kbt y square. Why am I doing it? To convert it into a gamma integral which is easy to solve. So t becomes m by 2 kt y square. Dt will be, so okay, t is this, so y will be what? Root over 2 kt by m root t, just taking the root of all the variables. So dt will be what? 2y dy m upon 2 kt, 2 can be cancelled out, and finally we get this expression by substituting y in terms of t. Fine. So outside this is already there, so I am just writing. Now what I have done is that this is an even function. It is symmetric with respect to y-axis. If you just draw it, it will be symmetric with respect to y-axis. This kind of a graph will come. So in that case, what I have, so what I have to do is that this kind of a graph. So it's a even function. If it is an even function, I can easily write it 2 into 0 to infinity this. So 2 into 0 to infinity, this thing becomes e to the power minus t. Dy is nothing but dt divided by root t, dt divided by root t. So I can write it from this, that dy is equal to dt divided by root t 2 kt by m to the power half divided by kt. This is what I will get, and this is there is an m also, so m is also there. So finally this as it is remains, 2 is there outside, so this has come. Now kt by m can be written now, and this m by 2 kt to the power half, because I have just written it in terms of in the numerator, and in the integral we will have t to the power minus half, which is 1 by root t e to the power minus t dt, and we know that it is popularly gamma of half, which is nothing but root pi. So to convert into gamma function I have done so much of steps. So e to the power minus m ax square kt by 2 and this 2 actually cancels to give root 2 root over kt by m. Just solve this particular portion, you will get root 2 root kt by m, and this is root pi from the integral. Finally inside the root we get 2 kt pi by m root e to the power minus m x square kt by 2. Similarly, if I solve the y integral, we will get the similar expression with this. Z integral if you solve will be this. Only this will change, ax square, ay square and az square. So finally if you multiply all those things, it will be just get added, e to the power minus m kt by 2 ax square plus ay square plus az square. This will be cubed, this root 2 kt pi by m will be cubed 3 by 2, and it is multiplied with this a cube, which I have not taken in any of the integral. I said that it is a constant, it will remain. This I have not taken in any of the integral, this always remains because it's a constant. So finally I have to multiply it. So this I have multiplied. You can see that is exactly inverse of this, so it will cancel out. Finally we will get this only. So e to the power minus mkt by 2 ax square plus ay square plus az square can be written as a square. Why? Because the magnitude of a is being given in the question to be taken as a. So finally we get e to the power minus mkt by 2 a square. So the correct option will be option C. So if I come back here, so it will be C is the correct option, that is e to the power minus a square by 2 mkt. So this is the correct option for this particular question. Thank you.